I'm Mesringer. In today's presentation I'm going to show you the calcination setup, and this is also going to be the contact process is catalytic chamber. For some reason this is a bit glitchy and the materials aren't showing up properly in solid edge. So this is a quartz tube, and this is a plastic pipe. It is like secured here with a steel wire thingy that is twisted at the end, and also glued here with some high temperature silicone. There is like I don't know, 25 millimeter gap here and 25 on the other side. I didn't put the plastic tubing here so we can have a better like see-through, and I'm going to go through the system. So this is a hilt strip. Didn't have the patience to make it this thingy, if you don't know what I'm talking about. So a screw is going to be welded onto this, and then we can screw this thermocouple screwing thingy. So the thermocouple has a wire. This is like a K-type thermocouple to a max 6675 type. What's the amplifier? What this is called? That's this, and you need to screw that in. In here, in the big gap, there is going to be rock wool placed, so that's going to keep this system nice and insulated. I have tested it out, and I think in like 2 minutes the heating element, basically this is it, the heating element, the wire, got so hot that the quartz tube end was actually glowing red. So not like bright red, but you know, that orangish that you can see even in the dark red. So yeah, it this was full like almost white. It got so hot, and the outside of the rock wool was only like 107 or 120 degrees Celsius, so it really got the heat trapped in there. Yeah, heating element, this is going to be powered from AC basically to 230 volts AC, and the power is going to be first fed into a transformer that's going to transform the voltage down to 6 volts, which is going to give us a 38.33 times amplifying of current, which is what we want, because we want a lot of current in this heating element so we can heat it up. The thermocouple is going to be connected onto an Arduino. The thermocouple reads the temperature. Let's say it's like 20 degrees in there, but I highly doubt that because it's cold as shit in the winter now. So the temperature is not the required, let's say 110 degrees, because of course there is need to be some empirical measurements that how hot the outside of the rock wool will get when the inside is, let's say, 400-500 degrees Celsius. So I will have to test it out, but I think like a 110 degrees is like a good starting point for me, but I will notify you about that later on. So the thermocoupler reads the temperature and sends that it's like 30 degrees or 20 degrees. It's not enough, so the Arduino is going to notice this and going to switch on the relay. That's going to allow the current to flow through the heating element, and with that we get heat. We heat the pipe up, the pipe section, this, and also the pipe, because it transfers the heat also. So yes, these parts here will be left uninsulated, so those parts will cool down more. So yeah, on the edges we'll lose a bit of efficiency with the conversion and also the catalytic activity later on, but with this we ensure that the plastic here is not going to melt. I have dedicated myself to use a high temperature resistant silicone, so this is like, I don't know, like up to 200 degrees C it holds on, so this is like a very high temperature shit. Yeah, this is really good for that reason, and we don't want to risk the fact that it's going to like melt or some shit, so let this 2 centimeters 20 millimeters there for air gap basically. And let's cut this bad boy up so we can see what's gonna happen here. So good old cross section here, we can see the elements wiring and also the thermocoupler inside. Here in this section, quartz wool is going to be put here. The rock wool is outside here, basically along the curvature inside the ring, but outside the quartz tubing, or insulates the wire or the element basically. I'm going to put the quartz wool inside with the metavanadate, ammonium metavanadate basically on it, and going to increase the temperature up to 400 to 500 degrees C, going to keep it around that temperature for like 2 hours. That's going to cause the ammonium metavanadate to break down into vanadium pentoxide and water and ammonia gas. That's gonna be puffed out right here, so this is why the end is not closed here. This end is closed. From this side, air is going to travel in with a little air pump. 1.2 liters of airflow per minute is going to come through the pipe, and it's going to cool the quartz wool down on one hand. So this is why it will be needed to heat it up a bit more than if there was no airflow, and also going to transfer some oxygenous basically for the ammonium metavanadate to break down and react, and the vanadium to form the pentoxide, to basically to oxidize into the pentoxide state. And whilst that's happening, hopefully like a 1 to 2 hours period of time at like 4 to 500 degrees C, and then when the actual calcined and will be like removed to inspection, then stuff it back in like quantities that are sufficient to fill up the space here between the two ends of the heating element. And basically what I aim to do is that in the past I have used something like this, that if you use like quartz wool or rock wool or anything like that, that's like a porous, but if you stuff it in too hard, basically it's going to block the airflow too much, and with that it's going to cause overpressure in here, and if the overpressure is too big, then it's going to shoot the thing out. If the end is closed, then it will just push it out and basically into the plastic pipe, then it's going to be completely useless here, because it's going to cool off there, and have to be very aware of that. Take it out, inspect it, and hopefully successful with the transition, and it will turn into a beautiful orange color, or at least orangish. And then I'm going to put it back in here, and I will be able to and even use this setup, just put the other end here and use this setup to basically make some sulfur trioxide from the dioxide that I will burn. So basically in here, in the contact process that I have made a video about, sulfur dioxide will come with air. The sulfur is going to be burnt in a chamber that's going to pump through with air in here, and through the quartz wool. And so with the quartz wool there is going to be vanadium pentoxide, that is the catalyst in this contact process. It's gonna be oxidized here and gonna go out in the trioxide version. And also I'm probably not going to use only just one, but like 2 or 3 of these, so I will be having a better conversion of sulfur trioxide in the end. But that's it for this video. If you enjoyed it and found interesting or anything like that, then make sure you subscribe and hit the like button, comment, all this bullshit. I know it's kind of cringe to ask, but it really helps the algorithm to pick up my channel and to get this information to other young men like you or women like you who want to get informed or know about these things, because these things I have to basically figure this out for myself, because nobody's really making videos like this that I could actually use and to get information about these kind of things. So for this reason, yeah, I make these videos. Without further ado, I'm done. So thanks for watching. See you in the next one. Do the hard work, especially when you don't feel like it. Mwah.